It's very difficult to create computer games. The problem is that's the one thing that all students who start programming want to be able to do. So how do we get around this problem? Today I'm going to show you how to create a two-dimensional games engine and explain the theories behind that so that you could build your own 2D game engine without having to worry about understanding how collision detection works, how parallax scrolling works, or how backgrounds and things move with a virtual camera. All you're going to have to concentrate on is what type of game you want to make and how you want to make it. The best place to start with our two-dimensional game engine is probably with the background. The background may be a single image such as the one you see here. That could be used as our backdrop to all our interactive objects, all the animated objects that have to collide and move around the scene. This is fine if you're only building a very small screen or level file, but as you move to larger levels, this sort of item can take up a lot of computer memory. It may be better if instead of building a background from one single image, we tell the computer, have a series of smaller images, such as these squares that you see in front of you, and build this set of squares up into a pattern, like so. Instead of having to store a large checkerboard pattern, all I would have to do is store the two smaller squares and tell the computer how to draw those squares onto the screen. Those squares don't have to be solid blocks of colour like you see here. They could be small images in themselves, such as a small piece of grassland or woodland. This is known as a tiled background, and our game engine is actually going to support both a single image and a tiled background. Tiled backgrounds are used a lot in games such as Pokemon and Zelda, where you want to have a huge map that you can explore, but don't want that to take up a huge amount of memory in RAM of your computer as you go through. Whether you use a single image or a tiled background, you set a width and height to your background in order to draw the image into memory. However, the game engine supports infinite backgrounds, which means that when you reach the edge of the background as you've set in your width and height, you can tell the computer to repeat it further. For example, you could tell the computer to stretch the background along the x-axis forever, in which case, as soon as you've finished one background, it repeats it again lengthways. You may tell the computer to repeat it downwards and upwards, in which case the background repeats again when you go across. Similarly, you can tell it to repeat both ways, in which case it will continue repeating on until the player finishes playing the game. Once we've created a single background image, we can tell the computer to set a certain colour to be transparent, and then from that we can tell the computer to layer multiple backgrounds on top of each other. There are many reasons why you would do this, the most important being something called parallax scrolling. Parallax scrolling is the effect you see when you look out of a train window. Items that are closer to you appear to move faster than items that are further away. One game that used parallax scrolling to a great degree was a game called Shadow of the Beast on the Amiga. This is a screenshot from it that you see here. In our background that you see here, we have clouds that are far away, clouds that are slightly closer, clouds that are closer still, and clouds that are even closer. We have mountains that are far in the background. Our player is this character here, and also we have these foreground items. So how does parallax scrolling work? Well, we tell the computer that we can scroll our screen at a certain rate. And then we tell the computer to increase this rate for any item that needs to be closer towards the camera and reduce this rate for any item further away. So for example, for every 1 pixel that we scroll the camera at our level that our player is, we might tell the computer to scroll these foreground items that we see here 3 pixels in the same direction. So it appears they move faster than the player, therefore it looks like they're close to the camera. We might tell them to move the clouds at the back only half as speed as we move the player, so they look like they're much further back. The mountains we probably set a value of 0. By setting a value of 0, that means they don't move at all, so they look like they're far in the distance. A virtual camera allows you to move around through the background by setting an offset and a resolution. For example, here we have a level file from Zelda, and I can move through the level file because it's larger than the camera screen. If I want the resolution to be higher on the camera screen, it's the equivalent of zooming out. If I want the resolution to be lower, it's the equivalent of zooming in. The level file itself is much bigger than the camera screen, as you can see here. So this is the equivalent of creating a tiled background of an entire environment and then telling the camera to have a certain resolution, say this, and starting at this location. You can control the camera to move it wherever you want it to go. You can even change the resolution while the game is still running, in which case it makes it look like you're zooming in and out of the game. But you can also see from this particular background how tiling works. Each tile is a series of small squares, patterns that are repeated over and over within the environment. Object collision with walls are a simple item to explain and understand. Here I have my item, my object. If at any point it collides with a wall, such as like that, I can measure which of the corner points and middle points have collided with that wall. So I can work out which wall it's collided with and which side of the object. So for example, I can tell it to bounce off, or if I was, say, moving up a wall, it might choose to slide and carry on until it reaches a stop point. As well as collisions with walls, you're going to have collisions with objects as well. Here we have two characters. If I move them together, I might want them to bounce apart if they're both moving together. If one of them moves into the other one, I may want it to collide with the other one and hit it into the side. The problems come when you then have to take into consideration the collisions between the objects and the walls as well. So for example, if I was to collide this object on this wall, after colliding with a player, there's not too much of a problem. But the closer I get, the harder it is for there to be any form of movement. If you don't get the engine right, sometimes this can lead to the objects all merging into each other and falling inside the objects. So what you need to do every time you make a collision with an object is check the collisions with the walls at the same time. Animations are accomplished by having the same image with a slight change repeated over and over. Here we have Sonic the Hedgehog, and you can imagine that you can cut out an image to use as our main character. If I tell the computer, after drawing this image, draw the one next to it, then the one next to it, and so on, it will make it look like he's an animated character. And this is how all animations in games generally work. When it reaches the end of the group, it then bounces back to the start. So seamlessly there should be a single object which looks animated.